I have a privilege to start this session. This is workgroup serving maintainers track. And today we will be talking about, we will introduce ourselves and then we will talk about workgroup serving, what it is about. We will give you update, and it's a meatiest part of a presentation, I think, about what are new challenges in 2025 in this world of inference. Then we'll go with subproject updates and talk about some work we do in Kubernetes and some other projects. And then we will talk about how to get involved. So with that, I want to say, I'm Sergey Kanzhelev. I don't have a badge on the stage, so you need to remember. I'm working for Google.
Hello, everyone. My name is Yuan Tang. I'm a senior principal software engineer at Red Hat. I'm one of the co-chairs for working group serving.
Hi, hello. This is Jiaxin Shan. I work in Bytedance as a software engineer.
Rita Zhang, I'm a software engineer at Microsoft and a contributor to working group serving.
Thank you. So is that, what is working group serving? Who knows? Okay, I'll tell anyway. So workgroup serving was created when we've been on the brink of AI/ML taking over the world, and we saw that there are a bunch of inference workloads, a bunch of serving workloads, and we are not sure that Kubernetes is suitable enough to run these workloads. So it was a challenge for us to understand how to change Kubernetes and adapt it for those new type of workloads, understand how these workloads will work, and get some real-world experience and apply it to all the projects we run. And then with this challenge, we actually didn't create just one working group. We ended up creating a bunch of working groups. If you feel like you drinking from fire hose of all the information you're getting, imagine working in Kubernetes and getting all these requests, like I want this feature, I want that feature. And all these working groups are created to shape those features more to get to the final stage of what we want to achieve. And there is workload-specific working groups like workgroup serving and working group batch. And we have workgroup integration that is a little bit higher level, talking about MCPs and how to do authentication stuff. We have device management working groups that is specifically hardware-oriented. And then on networking side, workgroup serving spun out the sub-project instance gateway, and then gateway is part of SIG network as well. And then we have a conformance program that is spun across all these working groups, and it has its tentacles into every single of them. So lots of initiatives, and under those initiatives, there are more initiatives with individual projects and individual SIGs. And all those projects are created to address challenges of the world. And with that, I want to pass the microphone to talk about these challenges.
Cool. Yeah, let's talk about some new challenges we identified this year. The first challenge is frequent updated model inference architectures. LM architectures are evolving super fast. In 2024, we used monolithic architectures, and this year, people start to use PD disaggregation. And starting from next year, I think the infrastructure will push it further, running the attention and FFN on different nodes within the role. Each architecture boosts the performance but raises the orchestration demands. Model roles now are first-class concept in Kubernetes, and orchestration needs to provide the separate rollouts and auto-scaling. And network topology-aware scheduling is also needed to collocate ping-pong stages. Additionally, native design for KV cache movements also become an expected case, not an exception anymore. second problem is in real clusters, there are several workflows fighting for the network cards. So there's the few scenarios, like case one, there's the east-west traffic between nodes. They are sharing the KV cache, like the status in the inference phase. The scenario two is kind of like a north-south traffic. KV cache can be offloaded to KV cache servers. And case three, like a model downloading and accelerations nowadays use the RDMA a lot. So they also need to use the network cards. The last case is the general like ingress and egress user response and control messages. So since each accelerator's architecture is so different, you need to carefully design the resource allocation, like the traffic to network card mapping and the NUMA binding to get the performance benefits for different architectures. So that's the insight too we get. For for LLM services, nowadays it's not a stateless workloads anymore. KV cache becomes the first class citizen in LLM serving scenarios. A lot of people feel struggled to manage the KV because these challenges. For example, if you downscale the KV cache servers, for example, like some of the hot cache KV cache might crash your TTFT and token throughput. And it's also very tough to estimate the capacity and choose the right DRAM size and replica size for your KV cache servers. And if you cannot concisely sync the KV event between the cache server, engine, and the router, you might not fully leverage the KV well. So the insight three is we like to declare the KV as state, make the router KV cache aware, and make the join and migrate hot cache KV by default. So there's also a challenge on the fault tolerance on Kubernetes. So if you have operated GPU clusters, you might see a lot of like GPU failures due to different reasons. So in current like MOE or EP models, the deployment becomes larger and larger. So even one GPU failure can stall the entire deployment. Failure blast radius is super large. You may like to ask, is it possible to reduce the blast radius? That's possible. So currently in inference engine projects like VLM, there's already ongoing proposals as the in-process fault tolerance to the inference engines, allow it to recover from certain failures without restart the instance. So after the RFC is down, different control plane frameworks can integrate the features to reduce the radius. Okay, let's move to the.
Yeah, next I'm going to talk about some of the subjects and initiatives we've been working on as part of the working group serving. The first one is the Gateway API Inference extension. It's basically a project that helps you improve and standardize the routing decisions and to optimize Gen AI model inference on Kubernetes. Here's an update of the project. Basically, the community is working on like making sure like the inference pool API and the EPP component are stable enough, and they actually went GA already. It includes features like prefix-aware routing and PD disaggregation support via LMD project. And after GA, there are some like plans already laid out, including scaling, such as a scaling tool from zero, and also like tune the framework, tune the fairness and queuing framework in order to better support multi-tenant and so on. Like the vision is even bigger than like LLM, so there are plans to expand the project to support other non-LLM models as well. The second project is the Inference Perf project, which is the Gen AI inference performance benchmarking tool to benchmark and analyze the performance for any inference deployments you have. And a couple of updates. 0.2 has been released, which includes automatic load sweeps, and load generators. Scalability and utilization have already been improved, and the team has also added support for SGLAN and TGI with additional metrics, and they've also expanded dataset support as well. And the community is actively working on releasing the major release, the first major release, and they are trying to add support for synthetic multi-turn chat, also trace, dataset trace replace support, and also in improving the CI/CD and testing for the project. And the team has also been working on the default harness under the RMD's sub-project called RMD benchmark. And the third project is the serving catalog project. The goals of the project is to provide working examples for different popular model servers, including VRM and other model servers as well, and also to support different open source models, and to provide examples for different deployment patterns, such as single node, multi-node, disaggregated inference, and so on. Also provide different primitives or examples for different primitives and also for different orchestration frameworks, including like road Kubernetes deployment, leader worker set, or K-serve inference surveys, and other additional frameworks as well. So basically a project that helps the community to explore different configurations and examples so that they can get started easily without looking up other many different resources. A couple of updates. So the project has recently added LM cache to the KV cache offloading capability, and they also added GCS fuse components for more efficient model weight loading and support for AKS and EKS templates as well. Next, we'll go through like some of the solutions and reference implementations. I'll pass it to Sergey.
Yeah, and before we go to specific solutions, end-to-end stacks that we'll be discussing, I want to say that when you look at workgroup serving and what it did is collected requirements, what needs to be implemented and how it needs to be implemented, and then ask questions. So you need this feature. What are you missing? And then we get an answer. And this answer will be quite complicated. You saw there's like many boxes, and then these boxes actually mean that you only need this communication channel, and then what is missing to implement this communication channel? And then the answer will be, oh, I need this metric to be passed here, and controller will react on this metric. And then, okay, to collect this metric, what you missing from environment? And in the result, we will often discover that Kubernetes doesn't miss any features, and it's not easier or more complicated to implement those stacks on Kubernetes or some other platforms. However, for some features, it's easier to go into Kubernetes and fix it, and that's where we actually needed to go and change Kubernetes or create new projects there. So one of the projects that we created in Kubernetes community is LWS, Leader Working Set, and this project was targeted to schedule multiple nodes together as single unit. And it's needed for multi-node inference when your inference model is so huge that you cannot simply fit it into one node. You need more computing power. There are other scenarios, like we have more and more scenarios when serving is not a single processing unit, it's like multi-stage process. So to satisfy all these requirements, we needed LWS. And if you see a new release, like in August, there was like 0.7 release, I cannot even explain properly what those features are. It's just like minor improvements over what we already had. So meaning LWS is already good enough. The biggest problem with LWS was it requires its own scheduling. So now we get to the stage, we know that LWS works. We know it can be used, and it is used by many customers. Now we want to use this LWS and make it native for Kubernetes. And that's why we do gang scheduling in Kubernetes, and it's going to alpha in 1.35, meaning it will be promoted soon. So LWS will feel very native with Kubernetes scheduler. Then with dynamic resource allocation, it's a similar story. We get requirements and people were saying, we want to run inference this way, we want to split resources this way, we want to have fungibility, we want to run on different type of hardware accelerators because we have scarcity of one type and a little bit more of other type. All those requirements accumulated over time, and we decided that device plugins that we used to have with a bunch of nodes just not satisfactory anymore. So we needed DRA as a solution. It took a couple years to discuss all the nitty-gritty details, how it will be implemented. And now DRA is in GA. DRA gives a lot of new features and capabilities. However, right now, DRA is just a promise of those new features because majority of clusters still using device plugins. We really need to transition everybody, all the clusters in the world, from device plugin to DRA, and transition is still a #1 priority for everybody. And it affecting like how we monitor device resources health, how we do provisioning of nodes. We want to get transition done, and then all the new features will suddenly be available to everybody. And among new features, other priorities are, we want to do multi-node support. It's quite high on priority list. We want fungibility. When we decide, workload will tell what it wants to have in terms of maybe capacity, maybe some other characteristics, and then whatever we have available from hardware, it will be given to this workload. And error handling and proper handling of unreliable hardware, which accelerators currently are, is a very good topic right now. And we see more and more situations when we cannot just tell device is healthy or unhealthy. It's kind of healthy. And this expressing kind of healthy is very complicated. And there are all other complications. And because of all these complication edge cases, you can see on a right side for you, there is a slides I took from a device management group. They were planning for 135 and above, and it just, I mean, just to listen all the features taken like half of a meeting. And yeah, I don't want to go into details, but those are priorities, and priorities are mapped very well to what we do in the DRA stage. And I wanted to highlight a little bit of other work that was some of it was initiated from this group, some of it was just inspired from this working group. We have a lot of inference workloads are characterized by heavy big files that have all the weights for the model. And this big file needs to be distributed, needs to be versioned, needs to be efficiently propagated everywhere. And this problem was still hunting all the clusters and still hunting all the inference workloads. And we wanted to have a unified solution for everybody. And instead of different vendors going different routes, saying like we want to distribute models as a disk image, we want to distribute as something else, we want to unify an image registry. And one of the things we did in Kubernetes is to we now allow images to back up volumes for the pods. And it's a great feature because now you can detach model server from weights, and now you can distribute weights in versioned and unified way. And another thing we have coming in Signode specifically, it's checkpoint restore functionality. It's also very useful for inference to pause and restore from a previous position. That may be very useful for inference, and we hope it will progress fast and soon. With that, we'll go to specific solutions.
Great. Yeah, I will talk about the AirBricks. So AirBricks is open source early this year. It is the cost-efficient and pluggable control plan. AirBricks provides the features like PD disaggregation, like intelligent routing and KV cache offloading, and also provides a dedicated specialized KV cache servers. And what makes the AI Bricks different is incubated from an end user company, Bytedance, and a lot of like enterprise features like batch API, serverless LoRa, and some other like multi-modality features has been developed and investigated here. That makes the like AI Bricks a little bit different, and it only focus on the control plane, but also have some integrations with the data plane, the engine side, to build some integrated solutions like what we discussed, like fault tolerance. Yeah, so that's the intro of the AI Bricks.
Next, I'd like to talk about LMD. So what is LMD? LMD is a large language model inference framework that runs natively on Kubernetes. This has been a collaborative effort among different companies, including some of the largest vendors. And 4 features we want to highlight here. The first one is the intelligent inference scheduler that allows, that leverages additional metrics from your model servers to and implements different filtering and scoring algorithms to help make intelligent routing decisions that's aware of your load, SRA, and PD disaggregation, caching, and so on. The second feature is PD disaggregated serving that's implemented via VRM's capability. The reason why that's useful is prefill and decoding phases are they have very different computational profiles and different demand. One is compute intensive and the other one is very memory bound. So by allowing them to have independent deployment optimizations, and we can achieve better performance. And the third feature is disaggregated prefix caching that allows the system to offload KV cache to either host or remote or through systems like LM cache. And the last one, but not least, this is one feature the community is working on called variant auto scaling. What they're working on is adding an auto scaler that takes into account different types of variants, including hardware, workload, and traffic, so that the inference can be really optimized based on different dimensions. This is really useful for like heterogeneous setup when you have like different hardwares and different characteristics of your inference workload. Next is Kserve. Kserve is a standardized, distributed, and scalable model inference platform on Kubernetes. What's unique about it is that it supports both predictive AI and generative AI. So if you have traditional ML models that's smaller sized, you can use it with different predictive frameworks such as XGBoost, scikit-learn, PyTorch, actually not PyTorch, but like GBM. And if you want to use generative AI capabilities, you have lots of choices, including VLM and SGLang. Kserve also provides lots of different Gen AI integration. We recently added in our recent release, the 0.16 release, that includes the LMD integration, so that you can use the intelligent routing and disaggregated serving from LMD. And we also added Envoy AI Gateway support that provides additional limiting capabilities, and RM cache support to offload your KV cache. And we also provide additional integration with the cloud-native technologies, including like Knative for event-based Knative, and KIDA for event-based auto-scaling, and integrates with lots of different networking implementations as well. We recently just announced that we just joined CNCF as an incubating project, so we really want to work with the rest of the community to make sure like all these integrations work well together. Okay.
All right, two more projects in case you thought there was a lot already. So I'm going to talk about Kaito first. So Kaito is a Kubernetes AI two-chain operator, and for the sake of time, I will just focus on the differentiation because I think at this point either everybody is about the same or will be about the same. So for Kaito, what is in the very beginning, the project wanted to ensure that users can auto-provision GPU nodes with something like Carpenter, because we heard a lot of users say, hey, I don't want to leave my GPU nodes idle. I don't want to pay for it unless I'm actually using it. So this is something that a lot of our users really love because you only need to provision the GPU nodes when you actually run your inference. Secondly, again, like everybody else, is supporting all the common inference runtimes and also LM cache and GIE. And then also, the project also supports LoRa fine-tuning, and now it also has multi-node distributed inference support with Ray. And also, the project also has a bunch of presets for commonly used open source models. And based on a lot of the tests that the project has done, it actually recommends specific GPU, CPU combination and resource requests and limits so that you don't have to think about it and make sure that you don't end up with OLM kill, right? Another one, like everybody else, now it's integrated with Kata so that we get auto-scaling. And then last but not least, recently the project also integrated with Kubefleet to support multi-cluster inference routing. Another differentiation is the project also has a RAG engine. Again, we heard a lot of users really want to use RAG to leverage the open source models, and this is where a lot of users really love the project. And at the bottom, we've also recently done a collaboration with LMD where we use LMD for inference, and then you can use Kaito's RAG engine to fine-tune your models. Another one is Dynamo. This is probably a bit newer than the other ones, and it's an open source project that was open sourced by NVIDIA, and recently Microsoft has been collaborating with NVIDIA on this project quite a bit. Where this project really shines is performance. You probably heard Jensen saying performance, performance, performance. And so they've done a really good job of integrating with Nixel at the network layer to optimize, again, disaggregated serving, but also ensure that it supports multiple inference engines. I think a lot of other projects currently do not have this, which is something I think is pretty cool because your models don't just use VLLM, right? There's transformers, there's TensorRT, there's also SGLang, right? If you want to run DeepSeek R1, you're probably needing SGLang for your inference engine. Again, another differentiating feature it also has is this thing called a SLO-based planner. So basically, you can tell the project, hey, this is the throughput and the latency that I'm looking for, and based on that, it will actually recommend the number of prefill and decode containers that you need to run in your cluster. So it comes in very handy. Another one is, I think it's the latest one, it's called AI Configurator. Basically, you tell it what model you want to run, and it actually recommends the type of GPUs that you should be running with. And with that, I also want to talk about the latest, greatest certify your Kubernetes clusters for AI conformance. In case you missed the keynote, this working group is also collaborating with the AI conformance program to make sure a lot of the learnings that we have gained from the working group actually gets back to the AI conformance program. This program started actually in August, I think, and we just rapidly define a lot of requirements that ensures that when you get a Kubernetes clusters, it already comes with a lot of the plumbings at the infrastructure level. So you as the Kubernetes operator, you should not have to think about what kind of device operator, the device is running in the cluster. Does it have the storage that I'm looking for, right? or does it have DRA enabled? Does it have the DRA drivers installed? So again, to reduce the amount of work that the Kubernetes operators have to deal with. And as of right now, a bunch of companies have been certified, and we definitely want to welcome you to join that effort to help shape the future of this program, especially you're on the ground running, and please come and share your use cases.
Okay, that's a lot of projects and initiatives and working groups, right? So how do we work together better? So we'd love to hear any feedback and suggestions on how this working group can work together going forward. So if you do want to participate going forward, please let us know. We have links. If you click the link for the working group charter, like you'll find access to like Slack workspace, Slack channels, and community meetings and so on. And reach out to one of the co-chairs or community members if you ever want to present any topic at the community meeting. So we'd love to hear more ideas. That's it. Thank you.